Okay. So in this particular course, we'll be discussing the antenna. The course name is Antenna Theory and Design. But here, because it is an elective course, I have a lot of freedom to decide the course module, to decide the way of I teach, and also decide the evaluation scheme. So, the course has a different kind of theoretical aspect, some design aspect, etc. But I'll tailor the teaching based on the current requirement and based on the design. And I believe some of you are already working in the area of RF and microwave engineering, mainly the antenna engineering, to be more specific for your final year project or related area. So I will probably this course will cater to their requirement also. So as far as the theoretical parts are concerned, there are a few fundamental antennas like dipole antenna, monopole antenna, antenna parameters, different kind of parameters to evaluate the performance of an antenna, and then additional parameters to design array antenna. Those things will be covered. I'll be following Balanis for that part. But later on, you will see I'll give a lot of design problems, which will probably create a lot of interest, where I'll be involving the different kind of electromagnetic solver, which are commercial solver like ANSYS, HFSS. Maybe few of you have already used also. And then CST, computer simulation technology, or sometime you will be doing some coding in MATLAB for designing array antenna or array synthesis, etc. Here, more than theoretical knowledge, your own design ideas, of course, using the theoretical ideas that I will be teaching in the class, will be actually encouraged. So I'll be giving different kind of problem statements which are related to the courses, but then you can improvise it further to make a practical design or different kind of applications. So there different kind of designs, like I just give you few case examples: the dipole antenna or monopole antenna, or you have seen the array antenna, which are deployed in ground station applications like Yagi antenna or parabolic reflector. This can be easily designed in different kind of softwares, and most useful software which is readily available with us is the ANSYS HFSS, High Frequency Structure Simulator. So there, I'll ask some of my PhD students to take a couple of classes to teach you the software. Maybe few of you are already using the software, those who have done internship in this area. But in general, we'll have few sessions, maybe 2 sessions or so, for training of the software. And I'll, take you to the lab also, because once you design the antenna in the software, it might be difficult for us to fabricate this design. But we have already a lot of fabricated antennas, some of which you are going to design using your own simulator. Then those fabricated antenna can be tested in our anechoic chamber. Probably you have seen in the advanced microwave like C102, you have our anechoic chamber. So you can, you'll get a thorough, ideas on practical measurement of antenna, which is very, very difficult to get in undergraduate or even postgraduate states. States in most of the universities, even abroad. So you will get a thorough chance of learning the software. Understanding the theory, then learning the software, design the antennas using those softwares. And I'm not guaranteeing that you can fabricate. Actually, those who are will be doing a good design, we can fabricate also, because we have fabrication facility. But I'm not guaranteeing that part. So in that case, we'll give you the prototype antenna which are available in our lab, or which are designed and fabricated by previous students, mainly the PhD and master students. So I'll take you to the lab and I'll teach you how to do the practical antenna measurement, the pattern measurement, the measurement of S parameter of an antenna using vector network analyzer. These are very, very practical training, which is very essential for RF and microwave engineers. And because the course is taught in a different way, not in a conventional chalk and talk approach, so of course my evaluation scheme has to be different, because I am involving you in design, I am involving you in software, and then involving you in measurement, etc. So naturally I have to tailor made the evaluation scheme. Some written component will be there, like quiz, and the NSEM exam will be there, but I'll try to minimize the weightage on that and try to increase the continuous evaluation, continuous learning, mini project based evaluation, because I'll be giving some additional problem statement based on what I am going to teach, and based on some of the recent literature from different papers, mainly the IEEE papers and all. All of you will be given a little challenging assignment where you have to come up with a design on your own, and I'll give some kind of weightage on that particular part also. But having said that, if some of you think that you don't want to get evaluated through a mini project, I can conduct a written exam for that particular component for those students. I hope I have not confused. What I am telling is there will be some component for the continuous evaluation will be flexible. That is your choice. You can choose whether you want to be evaluated based on a mini project that will involve software, that will involve your own design equation, and probably replicating some good paper from IEEE, which will be selected by me only. Option 1. Option 2 will be, if you feel okay, you are not comfortable in that, you want to be evaluated in a classical scheme using a assignment or using a written exam for that particular component, that is also possible. So that part will be option. I have not yet decided, but I'll try to reduce the marks on the NSEM and the quizzes. Probably I am planning to make it 50-50 kind of thing, or maybe 40-60. I'll talk to because new NEP new educational policy, National Education Policy 2020 has given a lot of freedom for the evaluation scheme, etc. I'll just talk to the Professor Selvana Nation and probably Dean Academics. Should not be a problem as far as I know. So that will be an evaluation scheme, a flexible evaluation scheme for some component. Coming back to the course, everything will be taught, but in a different way. Like microstrip patch antenna, normally, most of the places it is taught from Balanis, which is hardcore theory. But here, along with the theoretical part for microstrip patch antenna, all of you have to design a microstrip patch antenna for given frequency, for given application, like 2.4 gigahertz antenna, or someone will be designing an X-band microstrip patch antenna, say rectangular patch antenna, or a circular patch antenna. You have understood the concept of polarization in your electromagnetic theory course. How we can design a linearly polarized antenna, how we can design a circularly polarized antenna in a practical way using the CAD tools, the computer-aided design tools. We are going to learn on this course, through this course. And then we have a little advanced thing like array antenna, where multiple antenna elements will be placed in a close proximity. I am not going to teach the theoretical aspects today, but there is some rules, thumb rules and all. What would be the periodicity, the spatial periodicity, what will be the phasing between the individual antenna element to make a broadside pattern or end fire pattern. All these things will be taught initially theoretically, but then in this particular part, I'll ask all of you to use MATLAB to come up with the array pattern analysis or array pattern synthesis. So linear array, planar array. Here, I believe most of you know MATLAB, and you are normally very strong on this kind of aspect. You can easily learn, and I mean learning through joy actually. That is very important. So whatever you are learning using equation or some of the derivations I'll be doing in the class, you can easily corroborate those ideas using the software as soon as we give you a problem. Then some of the practical designs of antenna like Yagi antenna, log periodic antenna, biconical antenna, then antenna which are used for ground station applications. You have seen for our airspace lab, the ground station in aerospace building. So all those antennas, most of those antennas I'll be teaching in the course, and quite a few of them you will be able to simulate. The horn antenna, like the Cassegrain type of horn antenna. And towards the second part of the course, once the fundamental part is over, which I'll be using Balanese, I'll be using a significant part from our book. Like we have a book where I am the primary author with Taylor and Francis CRC Press. So multifunctional antenna, reconfigurable antenna, new ideas of antenna design using the metamaterial concepts. So some of these advanced things also I'll be covering. And there our book and some of our research article, even some of the current things that is happening with National Remote Sensing Center and some other ISRO centers, I mean ongoing research. So from there also I'll cover some part. Okay, so as I said, the teaching scheme will be different, evaluation scheme will be slightly different. I can show you the course syllabus and discuss, but that is probably not needed because you can go in our website and see the course module. As I said, dipole antenna, loop antenna, monopole antenna, antenna parameters, some analysis, and then array antenna, microstrip patch antenna, some of the aperture antennas. These are there, written in the syllabus. I'll cover all of that, but from a different perspective and in a different way. So I stop it over here and let us make it interactive now. Yes.
Oh, okay, sir. Great. Sir, you told you can make it 40-60. So 60 was for design or 60 was for papers?
Yeah, well, 60 will be maybe for continuous evaluation. Not only one design, quite a few things.
Okay, sir.
Yeah.
Actually, 60-40 in that sense is very great because in that case you can employ more, emphasize more on the design part.
Right. And another point, those who will be taking the course very seriously and will be investing time on the design aspect, probably many of you will come up with new ideas and, try to get benefited. Maybe a few of you can come up with some IEEE paper also. IEEE high quality conference paper or stuff like that. It has happened earlier. Not everybody, but I have seen some of the students have come up with some design which is improvised, which is slightly new, and that has been published in I remember quite a few cases because 2013, 2014, 2015, even 2016, these 4 batches I offered this antenna elective course to the BTech students. I think that time it was in 6th semester. Anyway, it is same only. But then later on, I was not here for 1.5 years. That time I could not offer the course. I went to Canada, and that time some other faculty members started offering, and then I got engaged more into the MTech teaching. So last 3-4 years I could not offer this course. Yeah. Others? Nimesh?
Yes,
How are you,
sir.
Nimesh? How was your experience in Kharagpur?
Sir, it was good, sir. I had some hands-on experience with ANSYS HFSS also.
Mm-hmm.
Yeah.
Okay.
Overall, it was fine.
Okay. Did you design Python? Use Python for some of your stuff?
Sir, yeah, actually we worked with Python. We worked on developing Raspberry Pi codes using Python, but in reality, most of the work was done by our MTech, right? The person who was from MTech in IIT Kharagpur only.
Who was teaching you initially, right? I was present in that first meeting.
Yeah, actually he had very good knowledge in programming and all. So you can say that most of the Python work was his contribution only.
Mm-hmm.
So I
No problem.
yeah.
You can make a presentation sometime to me to explain what you have done there. Anyway, you have to make an internship report also, right? Presentation.
Yes, sir.
Where is your friend? Other friend who went to Kharagpur?
Sir, I think he is not here, sir.
Okay, so I think you have learned HFSS. That will be more helpful for you.
Yes, sir.
Yeah, yeah. Anyway, others don't get panicked. You are not good, and I'll ask Gopika or some MTech students to spend couple of hours for the software, because software will take a important role. You'll get the software student version. All of you will get in your laptop. You can use that, and if needed, if the design is little complicated and heavy, you can come to our lab, or you can use the HPC lab, and you can do a fast design or a better design using that. Okay. Anything else from anybody? Atul? Hey, you should open up. I said it will be interactive, right?
Yes, sir.
Hmm.
My internship was also great. Sir guided us so well. From very beginning, he used to guide us, me and Rupert, every day. If any single problem occurs, he guided us and taught us in a very well manner.
Mm-hmm. Okay, very good. Yeah. Yes, Aditya, you have any further question on behalf of the whole class?
No, sir. Palvinder told me he'll not be able to join. Later on, he will join. I will inform him. I've also recorded the session, which I will forward it to people who asks me.
Oh, maybe you have done audio recording, not in the Google, right?
No, sir. Not in the Google. I recorded my screen, but in my simulation, my laptop was going on, so that also got recorded. So I will share it privately. Whosoever needs it.
Okay, no problem. Then fine. If you have further questions, please ask. Otherwise, we'll stop it here. And Monday, as per the schedule, I'll start taking class. Okay?
Okay, sir.
Yeah. And Aditya, sometime you may meet me tomorrow, because we might need some kind of adjustment in the hours.
Okay, definitely, sir.
Instead of taking 1, 1, 1, I want to do 1 plus 2.
Sorry, I did not get it. 1 plus 2 means?
1 plus 2 means 1 single class and 2 double class.
Okay, sir.
We have 3 isolated, like Monday, Thursday, or Friday, something is there, na?
Okay, sir. Should I identify a slot where we can?
Yeah. It will be good. You just identify few options, because I have MTech also.
Okay, sir.
So that has to converge actually. Your choice and my MTech courses. Okay. Maybe sometime you meet me tomorrow.
Okay, sir.
And then we can discuss.
Okay, definitely, sir. Okay. So
Okay then. Thank you. Good night to all of you. Yeah. See you on Monday.
Thank you, sir.
Yeah.
Good night, sir.
Good night.
See, the thing is, you may walk with no hopes, having your head, your vision towards the street or down, but ultimately you will sometimes see a sky, because sky is something which is hard to achieve, which requires confidence,